When I was younger, I worked at a mom and pop deli, making sandwiches, stocking shelves, mopping, that sort of thing. But one of the other things that I did was to run the register. One day though, something goes out. I think it was a fuse, the building was kind of old, but the end result was that the register stopped working. Great. They knew that I was a mathy kind of guy, so I ended up having to do sales in my head, which wasn't too bad as most people only got a few items, only had to add a few things, and the tax rate was 5%, so that wasn't too bad either. Still, I'm only human, so I ended up having to use my calculator watch for some of it. Yes, I used a calculator watch. Fight me. At the end of the night, the owner had to check my math to make sure his books added up. This came in two parts, making sure that I correctly tallied up each customer's subtotal, the amount they would owe before tax, and then making sure that I correctly calculated the total, which is the amount they would owe after tax is applied. Spoiler alert, it was right. Though he had a computer, he didn't know much about how to use it, so he just ended up using a hand calculator. But is there a faster way? Let's take a look at the mechanics of what he did. First, he had to add up the customer subtotals. I can't really think of any way to optimize that. The second thing he had to do was to calculate the total with tax over and over again. This is where we might be able to speed things up a bit. You see, we have spreadsheets into which we can type stuff and significantly reduce the amount of typing we have to do overall, possibly by half. Cutting a few minutes of work in half might not seem like that much of a time savings, but at the end of a long day, frustrated by the loss of your register and having to deal with a really tall guy making bad math jokes.
Hey guys, why was 6 afraid of 7?
Let's just say you're counting the seconds. Don't worry if you've not used spreadsheet software before. I'll tell you what you need to know.
I've taken a minute and just typed out a bunch of subtotals, like what the owner might have seen. That's this here. I've also typed out a bunch of totals with tax, like what I might have calculated and then given to him. That's this here. Lastly, I've got a calculator that will simulate what he used to check my work. If the tax rate is 5%, then to find the total with tax, you take the subtotal and multiply it by 1.05. That is 105%, which comes from 100% plus 5%. The first total is $45.22, so we multiply that by 1.05, and we get $47.48 and a tenth of a cent. For now, we'll round to the nearest penny. If the trailing digit is 0 through 4, we'll round down, and if it's 5 through 9, we'll round up. Anyways, what that gives us is $48.48, which is what I got. Next, we have $5.99. Multiplying that by 1.05 gives us $6.28, which will round up to 29 cents. Next is $8.25. Multiplying that by 1.05 gets us $8.66. Check. Next is $10.99. Check. You get the idea. And there you have it. After checking each value, it turns out they're all correct. Hooray! Notice how each time I do this, I'm just multiplying by 1.05 over and over again. Wouldn't it be nice if we could come up with a formula that would let our computer do this automatically?
This is where spreadsheet software comes in. To use it, we'll need to come up with a formula to type in. Once we do that, we're all set to make it work for us. Let's write out in plain English what we want to accomplish. We're going to take the subtotal, multiply it by 1.05, and that will give us the total amount. In math, we call these variables. That is, the subtotal will vary from instance to instance, just like the total will. Strictly speaking, the total is called the dependent variable because its value depends on the subtotal. By contrast, we call the subtotal the independent variable. Lastly, the only other part of this formula, the 1.05, is called a constant because it doesn't ever change in our calculations. Okay, so back to the computer.
For clarity, I'll make two labels, subtotal and total. This part is meant for people reading this. From here on out though, everything is going to be typed so that the computer can understand, which needs us to enter information in a very specific way. I'll type the first number in here, $45.22, under subtotal. To let the computer understand the formula we crafted, we have to type it in as follows: an equal sign, which lets the computer know that what follows is our formula, 1.05, our constant, an asterisk, which is the computer's version of a multiplication symbol, and A2, which is the name of the cell where we typed in our subtotal. Now we hit enter, and boom, there's our answer. With this, all we have to do is to type in values under subtotal, our independent variable, and we get values for our total, the dependent variable. As you can see, the variables are essentially placeholders. That is, they're waiting for us to come along and put in a value, or to have one generated through calculating the result of a formula. This cell right here is the placeholder for the independent variable, and I can type in all the numbers I like to make this calculation go faster. And that's it. Job done. All the numbers checked out.
There are many contexts where variables get used. Spreadsheets offer one for us, but it's nowhere near the only one. In programming, variables are used all over the place and can represent all sorts of things, from numbers and letters to pictures and sound. In mathematics, when we write out equations and formulas, we use variables to solve whole groups of problems at once. In all contexts, from programming to pure math, there are carefully crafted rules to facilitate getting stuff done. In programming, these rules look like syntaxes so that people can express their thoughts in ways that computers can understand. In math, these rules take the form of a sort of shorthand, as it's often written by hand, which is very handy. For example, let's take the formula we just generated and rewrite it in a classical math shorthand. First, we need to use single letters to represent variable names instead of whole words. With that in mind, let's rewrite the independent variable subtotal as merely the letter S, and the dependent variable total as the letter T. This is shorter already, but there's another, perhaps more important benefit to rewriting variables with a single letter. It avoids confusion with another of math's shorthands. Writing two things next to each other implies multiplication. For example, we can and should rewrite S times 1.05 as 1.05s. This shorthand is incredibly common, and we'll get a lot of use out of it in the near future, both in terms of expedience of reading and writing, but also clarity. The way we would actually use the formula in this math context would be to substitute in or plug in a value. That is, we would look at the S and replace it with the subtotal in question. To do this, we would write it like so: 1.05 parentheses 45.22 end parentheses. We will learn later the details about why we use parentheses like that, but for right now, just understand that it's to preserve multiplication and other operations. We can then carry out the process, giving us 47.481, which we would round to 47.48. We could then plug in other values, which would look like this. Okay, so to wrap this up, the headline of the video could be, a variable is a placeholder waiting to take a value. The value it can take will come from the context of the problem. Constants are values in formulas that don't change. The dependent variable is the one that results from plugging in a value for the independent variable. You substitute it in, you do the calculation, and you get the result. In future videos, we'll talk about various formulas and how independent variables draw values from a collection of them called the domain, and how dependent variables collectively form a set called the range. We'll learn why we need parentheses to plug in values, and all sorts of other things. Thank you to all my patrons for helping to sponsor this. I couldn't do it without you. Thank you to Origami for all that you do, and congratulations to you on reaching the next term in your own Taylor expansion. I'm Derrick Taylor, and I'll see you next time.
Thanks for watching. If you like this video, please click like and subscribe. If you really like the video, come on over to our Patreon page where you can get involved and see all the cool stuff we're doing.
Hey guys, why was 6 afraid of 7? Because 7 ate 9. But why did 7 eat 9? Because it needed 3 square meals a day.